Hi, my name's Stephen Brown, and the title of my talk today is We Are What We Think We Eat. I need to fly through the background somewhat because I've got too many slides, but I just need to highlight that some of this work, I'm going to cover two studies which I'll touch on in a second. The first one done at University of Bristol, and the second one more recently done at University of Aberdeen and written up while I was at Sheffield. Those two studies, the references are given here. The first one, essentially an early experiment looking into expected satiety. Now, expected satiety is based around when you look at a piece of food, you expect it to stave off hunger for a period of time, and that period of time will be longer or shorter depending on the food that you're evaluating and the portion of the food that you're evaluating. And we wanted to look at the effects of those expectations on reported hunger and fullness. So I'll go in some detail about that study. A later study is essentially a follow-up of that. I'll explain more as I go along, but essentially we wanted to replicate some of those findings with a solid food, and we also wanted to do it over a slightly longer time period between when they had the food and when hunger, fullness and later consumption was measured. And we also wanted to measure whether Ghrelin response could account for the findings within the behavioural and self-report data. So just to give a little bit of the background and kind of place the work in a setting, there's essentially a need for a kind of win-win solution to the problem of obesity and the health consequences that occur as a result. Arguably, food companies contribute quite heavily to the problem with overweight and obesity, but at the same time they need to remain competitive, they also need to placate policymakers who are obviously concerned with public health. In light of the kind of threat of taxes, fines and legislation, etc., there's more and more of a need for these win-win solutions that continue to make them competitive, but at the same time address wider society concerns about the health ramifications. The task for behavioural scientists is to try and contribute to the reduction in calorie intake. Now, this used to be thought of as a kind of linear line. As people reduced their calorie intake, they would either result in a flattening of weight increase, or they would reduce weight based on a simple 3,500 calorie rule. Research over the last decade or so has shown that this is a curvilinear pattern of weight loss over time. So the reduction in calories per person per day is estimated to be required to be around 300 to 1500 calories in order to either arrest weight gain or to result in weight reduction. Now, obviously, exercise has a part to play in contributing to that reduction in total energy, but the evidence suggests that that is not sufficient for most people alone. So we need to look at foods and how much is eaten and what portions are eaten in order to also contribute. Now, it can be, depending on people's diet, actually quite easy to achieve. 1.25 less chocolate biscuits can result in 100 calorie reduction in energy intake. 11 fewer crisps, or 3 few pieces of milk chocolate a day. So you can already get to 100 calorie loss quite rapidly. But what's the best way to start to reduce this intake? First of all, we could restrict, so essentially dieting. The problem with that is that it can lead to disinhibition, which then leads to overeating. And there's evidence to suggest even planning to restrict your food can result in overeating. Essentially, you think on a Friday, I'm going to start my diet on Monday. So then you start to shovel down all the foods that you're going to have to start restricting and that you're going to miss. And that can actually result in weight gain. If then on Monday, due to cravings and perhaps lack of planning, you then break your diet, as it were, you then are back to square one. You carry on eating these high nutrient-dense foods, and all that's happened is that you've gained weight. Even where it is a little bit more successful and people have a period of dieting, if they get a sense, for a certain group of people, if they get a sense that they've broken their diet, again, it can lead to disinhibition and overeating, and over a longer period of time, for the vast majority of people who try to diet in this way, it results in 95% being at the same weight or a greater weight within 2 years. So alternatively is that we could make it physiologically lighter, so people can eat the foods that they want, so they're not actively restricting, but the foods that they want to eat, they could be reformulated to be lighter versions. The problem is this psychologically can lead to a sense that you have permission to eat more. So if it's an adage of, if it's diet, I can have 2 of them. And there's evidence to suggest this across the board, but this one was quite a nice one, in that Subway diners, where it's kind of a health halo, underestimated what they ate by 37% compared to McDonald's, where people recognise that it's perhaps not the most healthy meals, and they only underestimated by 6%. You could also look to reduce it. But these are very much the kind of telling people the diet versions. You can also reduce them by reformulate the foods, but not necessarily telling people. So you can have a large variety of, in this case, pizzas that vary quite heavily in terms of the calories that they contain. You can indulge in the diet foods you want, the desired foods that you want, but you don't necessarily have that counterproductive consequence of restriction or affecting your expectations about how filling they'll be. With these foods, you might think, I'm going to be hungry in a short period of time, whereas something like this, without the labelling suggesting that it's diet, might not lead to that expectation of hunger. You can also maintain the same products, as it were, but you still reduce intake. So you still get to have your meat-based pizza. Sorry, the problem potentially here, though, is the lack of ability to regulate over time. You're essentially not getting the nutrient learning. So if you have a pizza like this, and you have a pizza like this, and you have a pizza like this, because of the reformulation that takes place, the different ingredients that are involved, you are essentially having a pizza, but with such huge variation in the energy that's being taken in, it becomes very difficult to learn about the nutrients within that pizza and to successfully manage portion size. So conscious reflective decisions to reduce intake can result in binge eating, preoccupation with food, and essentially weight gain. And the more hidden changes, they can potentially affect nutrient learning, they can affect potentially result in dysregulation, and essentially ultra high processed foods. There's also evidence there to suggest that there's a causal relationship between the amount of ultra high processed foods people eat and weight gain, and that's a particularly nice study if anybody wants to have a look at that. So this leads to the question, is there a better way? Now, many of the studies that are conducted use ad lib consumption, provide as much food as possible, not as possible, but provide more food than can be eaten in one sitting and measure how much people eat. That tends not to be the way people eat, though, in the majority of the time. You tend not to, for dinner time, fill your table with food, eat as much as you can or as much as you desire, and then bin the rest. What tends to happen is people go into their cupboards, select an amount of ingredients, prepare their food, and then eat what's on their plate. So it could be that these pre-meal cognitions that are made in awareness result in a portion size selection, and we could interfere in some way, in a positive way, that those pre-meal cognitions to try and reduce that portion intake or result in the portion that's selected conferring greater satiety. So essentially, it's looking to exploit external cues to take advantage of automatic processing and reduce intake without the resulting deprivation that you see in active conscious restriction, by utilising this idea of expected satiety and particularly increasing expected satiety. So just as a touch of background in relation to this, satiation is the fullness at the end of a meal. Satiety I've touched on is fullness over time, or the period in which a food will stave off hunger. And then what's important to note is that expected satiety differs for equi-calorie portion of the same food. So you're not going to feel as full in having 200 calories of peanuts as you would as having 200 calories of pasta. The evidence suggests that these expectations are learned. They correlate well with the amount of food selected pre-meal, and essentially all point to the idea that meal size is under a learned control, and it's expressed in the form of expectations that affect the meal selection before a meal begins. So maybe one day you have toast for breakfast, another day you have cereal, another day you have bagel, etc. The amount that you select and the amount that you prepare and then eat might differ over the different foods, but essentially will largely be under control. You won't be left with excess food. You won't have made half a piece of toast and then find that you're still hungry. They tend to be executed based on this learning that's already taken place. Very briefly, some work had already been done before we did our work, but it tended to be around explicit high-calorie foods that were labelled as such, and it led to the idea of, did people believe this explicit labelling? And it was only over short time periods, so people would be given a label of a snack that was high-calorie or low-calorie, and then 30 minutes later given an actual meal to see if it impacted, but that tends not to be the way in which we eat. So it led to some remaining questions. Can the expectations be manipulated more incidentally? And do the expectations affect fullness over a longer period of time rather than just this 20 to 30 minute period? So in study 1, we had 2 groups of participants. They came to us for lunch, but they fasted 3 hours beforehand, and they gave their initial reports of hunger and fullness. We then had a large group. They were shown a large amount of fruit that we purported to be being used for a smoothie, and a small group that was shown a small amount of fruit. The actual smoothie that both groups were given was made out of the midpoint of the 2 displays. So I think one was it was done on weight, but one was around 3 bananas and a bunch of strawberries. One was around sometimes only 3/4 of banana and just kind of half a dozen strawberries. We made the smoothies with orange juice out of those 2 midpoints. Participants were asked to taste the smoothie in the first instance and then report their expected satiety. That was done on a computer-based study created by Brunstrom and colleagues at Bristol. Then they were asked to consume it in its entirety, report their hunger and fullness immediately after, and then when they went away from the lab, they were asked to continue to report their hunger and fullness for the next 3 hours, and they had little buzzers to remind them when to do that. Our manipulation, the evidence suggests, worked. Those in the small group thought that it would be less satiating than those in the large group. And in terms of hunger and fullness, when in the small group, their hunger reduced more rapidly than in the large group, and their fullness, their hunger increased more rapidly and their fullness reduced more rapidly when they, for those participants who'd seen the small amount of fruit and therefore had lower expectations of how satiating the smoothie would be. So this work extended prior research to demonstrate the effect more implicitly. So we showed them those fruits as a kind of ethics check in order to ensure that they had no food allergies and that it would be suitable for lunch, rather than explicitly labelling it as high or low calorie. And the changes in hunger that resulted were of a similar magnitude or even exceeding the advantages that are associated with high protein foods. So if you have 2 equi-calorie foods, high protein is known to be more satiating, but in this case, just expecting the food to be more filling over time resulted in greater levels of fullness and reduced hunger. It also provided another link between actual satiety based on expected satiety. What wasn't clear is why this might occur. It could be that it's a physiological response, a kind of Pavlovian conditioning, that when we expect to consume a larger food, then we have a different gut-brain response. And in particular, there's some evidence to suggest that could be in the form of a Ghrelin response. Or it could be memory, it could be a cognitive issue, it could be based on when you're being asked how hungry or full you are, because our internal feedback is not fantastic, we kind of think back to our last meal to help guide us. And people who thought back to a larger amount of fruit report themselves as more full and less hungry than those who thought back to the smaller amount of fruit. What remains unclear is whether it's this physiological or cognitive explanation. Also, what happens if a solid food's given up to this point? There was no food that I was aware of or am aware of that's looked at it with solid foods. It tends to be soups, smoothies, yogurts, etc. And also, there was no measure of behaviour, i.e. later consumption, in our original study. So I looked to repeat this a second time. This time I gave them omelettes. I didn't have a pattern on the plate, but that's what I had when I was taking those pictures. They're not mine either. So what we did was we showed people, in this particular design, it was within participants. We asked people to come twice with a 1 week break in between. They were shown either 2 eggs or 4 eggs and different quantities of cheese, and the omelette was made out of the midpoint between the 2 presentations. So they both see the large and small. These were given at breakfast, so they fasted overnight. We measured baseline measures, hunger and fullness, BMI, etc. We counterbalanced presentation. The omelette was tasted again, exactly the same protocol, and expected satiety was measured using the same measure. They consumed the omelette in full. This time we asked them to give their immediate hunger and fullness, and then after 30 minutes, 1 hour, 2 hours, 3 and 4 hours. What we also did was we took a measure of that should actually be total ghrelin at those time points. After 4 hours, they were given a pasta lunch, and they were given weighed food diaries to measure their consumption for the rest of that day. And we asked them to come back after a week and do essentially exactly the same protocol, but seeing the small or large that they'd not seen before. The data showed that the manipulation worked again, though when participants saw the 4 eggs, they expected the resultant omelette to be more filling than when they saw the 2 eggs. These data are less clear. In terms of hunger, we did see a portion size and time interaction, but when we did the various t-tests and we did a bomb for any correction, None of them reached significance. We assume that it's happening around here, around this midpoint. In terms of fullness, while it trended in the expected direction, there was no significant difference. And then for whole day consumption, so this is them eating their omelette for breakfast, their pasta lunch, and then what was consumed in the evening, and as recorded by their food diaries, there was a average of 167 calorie difference between the participants when they saw the 4 eggs compared to the participants when they saw the 2 eggs. So they were eating more when they had essentially thought they'd had a smaller breakfast throughout the day. The changes that the differences we report above don't seem to be able to be explained by the Ghrelin response. There's a small problem, well, quite a major problem perhaps here, in that we measured total Ghrelin, whereas active Ghrelin would have been potentially a more acute measure to try and pick up differences there. So overall, our data provides some novel findings in that they suggest that you can manipulate the expectations for a solid food rather than just liquids and semi-solids. Our data show that there was still some effect on hunger, but not fullness. At least it didn't reach the level of significance. Furthermore, the data suggests that participants eat more over the day when they thought they'd consumed the small omelette in comparison to the large. That's incorrect there, as I showed on the other side. It's around 170 calories. And the Ghrelin response in this case didn't account for the findings. The evidence is somewhat mixed on that in other papers as well. We were in line with Hogenkamp, Hoffman et al., but it was in contrast to that study that I showed you earlier by Crum et al. So the jury's somewhat out in that. I largely think we were underpowered, and I largely think that we should be measuring active Ghrelin as opposed to total Ghrelin, but that's what these studies measure as best I can tell. In terms of implications, it might offer an opportunity to unknowingly reduce consumption without those negative effects of restriction or reformulation that we've talked about. If we can increase perceptions of expected satiety with packaging, etc., then it might lead to later reduction in consumption, or it might lead to smaller portion sizes being selected. Very tentatively, it might result in lower snacking between meals, given that there was a reduction in hunger based on that interaction around the middle of the inter-meal period. And again, very tentatively, I also wonder if some of this could be reversed, so that if you lower expected satiety, you might actually increase intake. And I think this could be utilised obviously for undernourished populations, but also military, and maybe even in relation to some sports. Finally, in terms of future research, we did it with high fat, high protein. Sorry about some of these pictures, that one's particularly gross, but I sourced these on Google. But we could use something like Weetabix here and hopefully show different amounts, and they wouldn't know what was in them once it was mixed. You could use slightly different weight of bowls as well when given that or that, and that's been shown to be done before with yogurts. We'd want to replicate the findings in general. We'd want to measure active Ghrelin. We'd want to do it over a longer period. This was only done one visit for each portion size. We'd want to repeat that perhaps over a month or more. And we'd also like to have a measure of memory. It would have been quite easy to do that. We just didn't include it. It could have just been recall for the prior meal. So I wanted to record this because I have children, and it's they can be quite screamy at times, but I'll be available for any questions if you wish to fire any my way.
So yeah, so thanks for that, Steve. Do you have any questions from the floor at all? Go on, Dave.
Thanks for that, Steve. I'm interested because you obviously showed the Weetabix type meal at the end there. What was the reason for kind of using the omelette as a meal?
Trying to work out how to show people two displays of different solid foods and then produce something that would mask what was actually contained in it. And I can only put it down to my wife telling me that she kindly made me breakfast a few times and omelettes when I've been in the gym and whatnot. And she said to me now and again she would put an extra egg in because there was one left just kind of sitting there. And I don't know if she thought it was lonely or what, but she'd put it in and I would never recognise whether it was a larger one or a smaller one. It was only when she told me. So it was basically that. When we first did the smoothie study, it was a real trial, a real task to try and find out what we could show people and then do something with and give them something else and they would believe it. We piloted lots of different things. We used, I remember going to Tesco and buying about 24 ready-made meals, macaroni and cheese and things, and using the diet version and the kind of full-fat version. And the plan was to swap the sleeves. The participants could look at them and look at the calories, and some of these were twice the energy from the diet to the main version. And when we measured their expected satiety, it didn't differ. And people were saying it's because they'll be the same volume in my stomach. Even though it's twice the energy, I'll still have 400 grams of, and I wanted to say, well, I could give you 400 grams of cardboard and, you'd still have that same, but there's a different amount of energy, but that's what they reported, so we couldn't use them. So that's why we went with smoothies originally. And I just played around in my mind and ended up with omelettes, to be honest, as something I could hide away. If there's alternatives, then I'm happy to hear them because that's one of the biggest tasks, to be honest.
Thank you. Do you have any other quick questions for Steve? Okay. I mean, I was just thinking there, Steve, with alternatives. I guess the obvious thing would probably be NCFI and looking at different, or potentially chefs. I mean, I'm not particularly good at cooking, but looking at different ways of putting different amounts of food together in appealing forms. It could be a useful way of testing those types of hypotheses.
I think so, and even kind of different quantities of if people are meat eaters, chicken and beef and things inside, dishes where it's chopped up and put in them and with like a sauce, those things can be hidden. I particularly like breakfast foods though, because I think it gives you that opportunity to measure for the rest of the day and gives you an overnight fast beforehand. But yeah, I think the carbohydrates might work, but then again, maybe not with the Weetabix. So.
Great stuff. Okay, all right. Well, unless you have any other final questions, I think we're a little bit stretched with time this afternoon. So I'll just I'll draw the seminar to a close today. So thanks everybody for presenting. So Dave, Caroline, and Steve for presenting today.